Der Fefe hatte mich gebeten, mich kurz zu halten, weil er hat mir Angst, dass der Talk nicht in die 30 Minuten passt.
Fefe asked me to keep it short because he's worried about it fitting in the 30 minutes that's allocated. So I'm going to pass it over, introduce you to anti-patterns and misunderstanding in software development. Just like you said, Fefe, that's the guy who used to have a column in the former news magazine. Here we go.
Which is Der Spiegel.
Hallo.
Hey guys, howdy. Thanks for showing up in such numbers. It's numbers I didn't expect. Okay, we're talking about anti-patterns. It's a thing that you do. You do a lot that cause problems to solve problems that don't solve the problem or cause more problems. And so I thought, at this Congress, there's lots of... So here's a motto that I find very profound, and that you'll see a lot why this is the motto as the talk proceeds. If you can read, the man who does not read has no advantage over the man who cannot. The structure of this talk. I'd like to demonstrate the structure. We're going to start with a problem, and then we're going to say SEAL Team 6 is on the job. And so think of a team of special experts. I'm sure they're all nice people. And then it comes into the implementation. That's usually when things go wrong. And then we have an effect, and hopefully we have become realization. So problem became problem factory. That's an allusion to Java. And so we also have an interactive component inspired by British Parliament. If you've noticed that people murmur when they sort of agree. And so instead of raising your hand, which could make you afraid and sort of out yourself, so if you recognize one of these patterns, please go ahead and murmur along like in the British Parliament. That is. So our first problem, this picture, I'd like to say, so it looks like we have was donated to me. It's a bunch of, looks like releases and zip files on a USB drive. I'm not trying to blame any of my customers. So it's a typical problem in software development is versioning and backups, maintaining backups of older version. I guess, hope you can see this is a USB stick. And so the idea that you have is a versioning system, and that's a good idea. And in practice, SEAL Team 6 is on the job again. And so the effect is Git. And Git is good. And there's not just Git, there's SVN, Bitbucket Perforce for GitHub accounts. And that's when things start to go wrong. I had a customer who used Git and told his...
And then he asked, which Git?
And so the effect of this is that everyone checks everything and everywhere.
And I'm sorry, we took them. Oh, okay. So just versioning isn't enough because somebody had permissions and just changed the things back that were changed in the versioning system. And another thing you get is people checking in binaries. And I'm not talking about images or screenshots or something, but binaries and executables, which is something you're not supposed to do. There are very few exceptions, and if you have one of those exceptions, you'll know it, and otherwise don't do it. And I mean, this is of course an extreme example, but I've seen similar things, and I've seen people check in different versions and not understanding what the point of a versioning system is. The image here was different zip files checked into the versioning system. And I always have a tip, and my tips is, well, Git is quite okay. I'm aware of the irony that my own software is on the internet as a CVS, but that's got historic reasons. Keep your patches small so you can deal with them separately. That's a huge problem if somebody has a huge multi-megabyte patch. Do a separate branch if you have to prepare some work to be able to apply the patch. If you have assumptions about versions and features that are that have to be fulfilled, you have to check that in a build script, and don't just start building, then abort after 2 hours. Check in the beginning, abort as fast as you can, fail fast. And in companies, there's often the idea that every different department has their own repository and separate versioning system, and that can work, but it does work very rarely. And that only works when you have stable APIs. And of course, everybody believes that their APIs are stable, but it's not. So don't do it if you can avoid it. All right, next problem. And that one is we always lose the bugs. And so the solution is a bug tracker. And the implementation is, of course, SEAL Team 6 just quickly hacking something together. And the effect you get is bugs everywhere. And, of course, that's the problem. We've got a lot of bugs. What do we do now? And a thing that I now see as an anti-pattern is priority. Something like severity blocker or security tag. And the effect of that is, of course, that everything else is left open. And you can see that again and again. What I see, what kills most bugs, or the highest amount of bugs, is when you remove a feature. And other than deleting such a feature, you don't get rid of these bugs. There's a nice word for that. Thank you for apologizing. Right, and he calls it a Bugwelle, which is the bow wave. When a ship pushes a bow wave ahead of itself, this is a pun in German. Okay, so we have the problem, we have so many bugs. And the idea is we reward bug-free code. Right, sounds good. Ideally with a bonus in money. You get a reward. And then, you know, that leads to you asshole opened bugs. I got a mail once where I recorded bugs, and I got a mail from someone saying, you ass, now I can't pay my mortgage. And I didn't know how to respond. He closed all the bugs and called it not a bug. It was his solution, which he promised me that he would fix all of them, but you can imagine how well that worked. So reward and incentive stuff, don't do it with money. It's tricky. But there is also an anti-pattern to that. And that was fixing all the bugs in the code and not closing them in the bug tracker. And his reason for doing so was, well, if I close them, then they don't need me anymore. And he saw all his colleagues being sent, the jobs being outsourced to India, so he just left the bugs open, and that kind of took my breath away. And I slept badly for a couple of days, because what kind of self-image has he got of himself if that bug tracker affects him so much? And it happens more often than you think. That people leave the bugs open, because if they close them, then the boss comes with the next to-dos, and if they leave the box open, they have a week of breathing room.
That's a common pattern. So here's another classic problem. You have an awesome project, and our code only works on the computer of the developer. And so your solution is make a build server. And so now we got a build server. It's going to build stuff. It's going to be awesome. SEAL Team 6 is on the job, and it looks awesome. Look, you got a drone-assisted building here. And so the problem is that the build server is built by a team and can only build the code of that team. And so the rest of the code is brought in as old artifacts, libraries, as a blob from some network store, and of course that sucks. That happens. And of course, builds are manually triggered. You have a build server, and someone has to manually go there and click to start it. If I tried to pull out a build, and so the idea of a build server is it does it automatically. And so if your build has failed, then the dev just logs in and fixes something, edits a file on the server, and fixes it. And in the growth of DevOps is something we're going to see more and more. It completely destroys the advantage of the build server. And of course, we have that same effect of only working on the machine of the developer, but not the one on his desk, but the one on the rack, the build server. And I hope that Debian takes up this naming convention. Debian Ramsey's the first with GCC. You see something like this really complicated setup. And that holds back the whole project because certain software versions that are totally normal things that can't do modern normal things like TLS 1.2 or like a really old C++ version, and so you can't use the new features, and so that sucks. And so, the illustration of this is this big pile of garbage. And so the idea of build servers is that you can do daily builds without having to go there and click things off, and without being able to go and fix things. And that they're deterministic and reproducible builds, and that you're more agile. So you can ask for things like build the version from yesterday at 5, and so you can tell when code being checked in breaks the build. And you don't want these crazy scenarios.
Es wäre mir sehr lieb, dass so Open-Source-Entwickler auch alle dafür sorgen, dass ihre Projekte mit beliebiger Parallelität baubar sind.
You want these build servers to also work in parallel without having race conditions where you can end up with having the wrong version because the other part of the build wasn't quite done. And if the build breaks, then I can just say I can do one click and roll back to the previous version, which still worked. And if you can't do that, then the build server is kind of useless either. And so the point is that ultimately you find really quickly who checked in or what checked in, something that broke the build. But of course the idea is not to punish that because I've seen a company where they had Britney Spears t-shirt and whoever broke the build had to wear that, and that worked well until they found somebody who was a Britney Spears fan. All right, so problem: the build only works on the developer's machine, and of course today you solve that with Docker, but of course that's not in principle a bad idea. But of course SEAL Team 6 just hacks something together, and it pulls some images from somewhere on the internet. And the classics is, of course, Debian Ramses II and MySQL, something from 19 whatever. Docker is not made for this. It's made for being able to change this in an agile fashion. And if you don't do that, then you end up with having a Frankenstein garbage project. I see that a lot in the industry where people take all the disadvantages but leave the advantages behind. And common effect is that you have components in sort of static versions that have been manually chosen when the build was set up, but they weren't updated ever. And I've seen people with build servers who build everything automatically, and you can see when things were built, and everything happens automatically, but they use versions from 2004, and that happens a lot. And if you notice in your company that components are being used in old versions, tell your build people. Otherwise, you end up with these walking aid for old people. You have containers for automated deployment in a deterministic state. And not everyone understands it, but it's also important to have a trivial rollback. If something breaks, then you just build the old version. And That's not a side effect. That's one of the features. That's one of the core elements of why you would use this container-based system. And I can just regenerate a new build. And that's why I also told you to check the dependencies in the build, so you can do it quickly and you notice when you do something, when something breaks. And containers also allow you to update components quickly and agilely, and it's not black magic, it's important, and I'm always surprised by how few people actually do that. And the last and quite important aspect is that you can isolate components separately, components from each other. And these containers are separate. So if one of these is hacked, then not all of them are compromised. But in practice, you can see that there is the monster container, which contains all of them, all of the components at once.
And so it's really good in combination where Git has all the versions, the build server has access to the state, the most current state, and then a container image falls out without any dependencies. The next problem is our code doesn't work, and so you probably heard of that before too. It's a problem, so what do we do? Unit tests, that's our solution. And so in practice, what do we do? When we fix a bug, then we'll make a unit test from it. And so to check if it's fixed, we make a unit test, yeah. And that's not good. And that way you get 2.3% test coverage. And I don't know if you know this video before. This was a machine for a soap dispenser, and it was made by white people. And so if someone with a different skin color went up to it, then they couldn't get any soap. And so that's a classic case of unit tests. Unit tests are there to check if the code is correct. Students are not there to check if the code is correct. They're there to check if the code is still correct. That is, when you make a change, you can tell if stuff still works. So you're not afraid to touch old code. That's what unit tests take off your shoulders. Because you don't understand that old code, and so the more coverage you have, the more confidence you can have when you are editing old code. And so, applause from the audience. Only positive tests. You have to run through this because I have so many slides, so you'll forgive me. And the next problem is that people only have positive tests. So how does that work? It basically is as good as having no tests because the most bugs are in error handling. And that's what you need unit tests for. And so for everything that can have an error, you need a test for it that tests what happens if this fails. And so that's the kind of stuff that causes another error somewhere. And so you have some memory corruption error or something like that. And then I have a remote memory leak and the process classes, and this kind of stuff is totally covered by unit tests. They're not a universal magic bullet. And even if you have 100% coverage, you could have missed some cases. And so they're tools for testing your coverage. Use them even if it's not perfect. The next case is our developer has missed some cases, missed testing certain cases. And so the idea is, do your tests first and then write the code, test-driven development. And I have no idea. I've never seen that in practice, so I literally have no idea. I only know people. The audience applauds at this. I only know people who are sure that this is the greatest thing ever. And if you've actually seen this work in practice, please send me an email because I'd like to see it. The next problem is, we have some code, but nobody has any idea how that works. And the solution is, of course, documentation. It's a good idea. I'm not going to say whatever, but, SIL times 6 sets up a wiki. That's our solution here. They're on the job. And so then the effect is wiki's down right now. It's throwing exceptions. The SSL certificate has expired, isn't valid anymore or something. That happens all the time. And so you get these sentences like, I think I put that in the wiki somewhere. You need to bookmark this. We don't have a navigation yet. and then, oh my God, all the time, that part up there isn't true anymore. So wikis is not a solution. The smaller of an effort you have to do to make a change, the less people actually end up contributing to this project or whatever. So the next idea that you see in big companies a lot of times is communication, needing more communication, people to talk to each other. And so open office is the solution, maybe with cubicles. And this is what it looks like.
It's an image of a crowded platform at a train station.
I have never seen this work either. Doesn't work. People have to be able to concentrate all at once, or sort of in one piece. And
people need to be able to focus for a certain span of time, and in an open plan office that doesn't work. And right now the trend is going to installing Slack and interrupting each other intentionally, and I don't get that at all, because after every interruption you need like a 15-minute time slot to get back into it. And all of these chat programs and mail programs need to they're designed to not give you that time. Meetings, I don't think I need to say a lot about that. But the effect is always the same. I can't focus. And that's a serious problem, and you have to actively work against that. And I thought about advising to keeping it short, but I've never seen that work. And so just keep it rare and keep it one-on-one. If there's something and you have to deal with it, if you have the whole team together, it's a higher barrier for somebody to say, well, I fucked up. So keep it one-on-one. Nobody wants to admit shameful things in front of their colleagues, but in a one-on-one you can deal with it. Okay, so we've got a problem. We've got code, but we don't trust what it does. First idea, we remove the compiler warnings. Good idea. But the effect, and I was shocked there is already a term for it, is onion code. And that means I have this huge chunk of legacy code with tons of warnings, and nobody has looked at it in 5 years, and somebody finds a bug, and then somebody fixes that, and but it still has all of these warnings, and I can't check in the bug because I would need to fix all of the warnings, but I don't understand the code, so I can't do that. So I add a little layer that just intercepts this bug and fixes this bug without touching the actual code. And when multiple people do that, you get these layers, you get an onion, and if you see that, burn it with fire. It's horrible. All right, so next idea, we release only without open bugs, and I had a customer who tried to do that, and then that leads to mails like, just close all of your bugs. And then my response was, well, I'm here to open bugs, not close them. And then they said, yeah, we'll reopen them afterwards, at which the audience laughs. I don't really have to elaborate whether they were opened or not. All right, so this hurts my soul because that's what I'm kind of do, external audits. Because what happens is that you get this sort of black box pen test, and that means the tester has no full access to the system. He doesn't know how it works. He should figure it out in the test, and then that's what you get. He shows a meme saying, says he'll pen test your network, screws around for 4 days, submits Qualys report. And that image existed before. Because what happens is that you don't test the code, you test the pen tester. And I, as pen tester, could say, oh, well, fuck it, I get paid. But I really have a higher moral standard. I would really like to help the customer. If you do this kind of messing around and not doing it, then don't do it. It hurts everyone. And part of that is that often these tests only happen due to compliance, and it's already terrible that we need that we screwed up security so much that we need compliance for people to still do security. So the idea is fuzzing. This is just giving random inputs until it explodes. And I've experienced that people said, well, you don't have to test this code. We've been running fuzzers for months against this. You don't have to check it. Unfortunately, they tested 2 billion times the same case. Great. So, of course, fuzzing is often a fig leaf that prevents other things from happening, because we've done fuzzing, right? What else do we need to do? I've got nothing against fuzzing. It's a great tool, but it's not. You mustn't neglect other measures because you've done fuzzing.
Or use it as an excuse.
And this is a general problem I've seen. Which measures should we take? Should I take the measure that probably works but doesn't give me metrics to quantify what I've done, or the thing that doesn't do a lot but that I can quantify very well? Management really loves being able to quantify things, and that leads to, well, that was really shocking for me. I have a good price value ratio, but I'm not cheap. And I get to this customer and he tells me to go home. I was like, why? Yeah, it's too warm today. You'll get paid anyway. And the answer was, well, the AC is only enough for one thing: the fuzzing lab or the consultants. And well, okay. And the last problem is sort of tricky, but it's very important to me, and it's kind of coming and getting bigger. Our coders are in over their heads, and we need a solid ansatz here, which is threat modeling. And every team has to do sort of threat models for the code, and that's good. And that is good. But ultimately it leads to the project manager or the feature owner to just filling out some forms, and the developers aren't affected at all. And that's a big mistake, because threat modeling isn't about the paper that comes out at the end. It's not about the certificate. It's about the road to that paper. It's about the developers looking at their code from the perspective of the attacker and making and thinking in that mode of thought. And if somebody else does the threat model, you can forget about it. You could have saved that. Threat model is good, but the developers have to do it. We're almost done here. I've got some more general tips. And because I can't let you go home in such a depressed state. From the point of the manager, it's really important to have this culture of errors where nobody is punished for bugs, but people who find bugs are rewarded. You have to reward people. Audience claps. You have to reward people when they find and fix a bug. Not with money, but with glory. And I propose, Fridays in the just before you stop, all hands meeting. Of course, if you have got something important to do, you don't need to come. No, forcing no one. But just a meeting where the old hands get to talk about their most awesome bugs, to promote this idea that bugs are a good thing, that it's interesting, that fixing bugs are good. And to get rid of this sort of rock star status, because that also doesn't really do. And another thing is to have the people who did the bug fix the bugs. In big companies, it's often that you have a security team that fixes the security bugs, and then the dev who is responsible for writing all this bad code never realizes that he writes bad code. And he moves around and he leaves bombs behind everywhere. And that's not to punish them, but it's for them to be able to grow and get better. They need the feedback to know when they made mistakes. And again, in the meeting, it's not about saying in front of the whole team, you fucked up. It's about, it's also a cultural thing. Different cultures can handle this better. But a lot of people have a big problem with being told that they screwed up. In Japan, it's terribly important to help the company and not be seen owing someone. And it's tricky to build this culture, but it's very important. Mistakes aren't bad. You can learn from mistakes. Mistakes are good. And the company has to communicate values. Like, it's more important to have good code than to have more features. It's important that when we wrote something, we get back to that and we improve it. And when we learn something, we go back to old code and improve it. And to do that stresslessly, we need lots of unit tests. There's a circle closing here. And then the other thing is that, an anecdote, a friend had a job and there was a user phase and we both had no idea. And then let's do it in Qt. And I was like, we don't have no idea of Qt. And he said, well, I want to learn about it. And it's been a few years, but if people aren't given time to learn things by the company, then they will learn these things in projects, which will then be screwed up.
Okay, and what you do see sometimes too is that management thinks that they want to prescribe the architecture of the software, of what database should be used, and that's almost always a bad idea, because either the architecture is obvious, in which case it doesn't help, or if it's not obvious, in which case it doesn't help because they misunderstood the problem. So that's the kind of thing that you should, sort of stand up to management on. And so a little more self-help for developers here. It's the last slide. Make the pressure come from yourself. Management talks a lot, deadlines here and there, but don't let that make you do overtime. Don't take any unrealistic expectations. You want to get home at 5. If they're making unrealistic expectations, you have to be very honest. This is probably not going to happen. I'll take the money, I'll work on it, but I'm going to tell you now, it's not going to work. And leave a nice little paper trail that it's not going to work out. And you can work on it because you need the money. A lot of you will, but be honest about expectations. Be open about expectations. It's a big problem in this industry. You have to think of management as you and management training each other, because as soon as you do this overtime, that's the new normal, and they believe that can always happen. And so the last sentence I have for time: you have to take time for yourself.
Raus mit dir!
Get out of here! He is overdrawing, and that's why everybody is laughing at this last sentence.
The sort of irony here, yeah. So I was just recommending that the management give you time, but if you wait for that, that's never going to happen. So I worry that the time for Q&A is over now.
Yes, it is, said the stage manager.
Das Beeindruckende ist ja wirklich,
so the impressive thing really is they all stayed here and nobody fell off the chair. Yeah.
Vielen Dank.
Thanks a lot.
Ausgänge sind beide offen.
Both of the exits are open. That's it.
Nochmal einen Applaus für ihn, bitte.
That's it from Feifei, and that's it from us here in the translation booth. Thank you for listening to the translation of Antipatterns and Misunderstanding.